Hello everyone, and welcome back to our channel. Today we're diving into a topic that's at the forefront of artificial intelligence, the fascinating world of GPT and its relationship with what we call traditional machine learning. Have you ever wondered how Netflix knows exactly what movies you'll love, or how your phone's voice assistant understands your every command? These are all powered by AI, but they often use very different approaches. In this video, we're going to break down the core differences between GPT and traditional machine learning, helping you understand these powerful technologies. Let's start with the foundations. Traditional machine learning. Imagine you're teaching a student to identify different animals. You show them a picture of a cat and say, "This is a cat." Then you show them a picture of a dog and say, "This is a dog." You repeat this process with many pictures, clearly labeling each one. This is essentially how traditional machine learning works. We feed algorithms vast amounts of labeled data, meaning the data comes with the correct answers or classifications. The algorithm then learns patterns from this data to make predictions or decisions on new unseen data. Key characteristics of traditional ML include its reliance on structured data. Think of spreadsheets or databases where information is neatly organized. Another crucial aspect is feature engineering. This is where human experts play a significant role, carefully selecting and transforming the raw data into features that the machine can understand and learn from. For example, if you're building a model to predict house prices, you might manually extract features like the number of bedrooms, square footage, and location. Traditional ML models are also typically task-specific. A model trained to detect spam emails won't be able to write a compelling marketing copy. Some common examples of traditional ML algorithms you might have heard of include linear regression for predicting numerical values, decision trees for making classification decisions, and support vector machines for finding optimal boundaries between data points. Now let's shift our focus to GPT, which stands for Generative Pre-trained Transformer. If traditional ML is like a student learning with flashcards, GPT is like an incredibly intelligent apprentice who has read every book, article, and web page on the internet. This apprentice doesn't just memorize facts. They understand the nuances of language and can generate entirely new, coherent, and human-like content. GPT models are a type of generative AI, meaning they can create new data that resembles the data they were trained on. They excel at tasks involving unstructured data, particularly text. What makes GPT so powerful? It's primarily its transformer architecture and the sheer volume of data it's pre-trained on. Unlike traditional ML, GPT learns from massive amounts of unlabeled text data, essentially by predicting the next word in a sentence. This unsupervised pre-training allows it to grasp grammar, context, and even subtle stylistic elements of human language. After this extensive pre-training, GPT can be fine-tuned for specific tasks with much smaller, labeled datasets. This adaptability makes GPT a generalist. The same underlying model can be used for writing essays, translating languages, summarizing documents, generating code, and even engaging in conversational dialogue. The key here is that GPT learns to represent knowledge in a highly flexible way, allowing it to generalize across a wide range of language-related tasks without explicit feature engineering by humans. So, what are the fundamental differences between these two powerful approaches? Let's break it down. First, data. Traditional ML models typically require structured labeled datasets. Every piece of data needs a clear tag or category for the model to learn from. GPT, on the other hand, thrives on massive unstructured datasets, primarily raw text from the internet. It learns by identifying patterns and relationships within this vast sea of information without explicit labels. Second, learning paradigm. Traditional ML often relies heavily on supervised learning, where the model is explicitly taught with input-output pairs. While GPT can be fine-tuned with supervised learning, its core power comes from its unsupervised pre-training phase, where it learns by predicting missing words or sequences in text. Third, task scope. Traditional ML models are often specialists. You train a model for a specific task, and it performs that task well. GPT models are generalists. Their broad pre-training allows them to be adapted to a wide array of tasks, even those they weren't explicitly trained for, simply by providing a new prompt or context. Finally, human involvement. Traditional ML often requires significant feature engineering, where human experts manually extract and select relevant features from the data. This can be a time-consuming and expertise-intensive process. GPT, thanks to its deep learning architecture, automatically learns and extracts features from the raw data, significantly reducing the need for manual intervention. In conclusion, while both GPT and traditional machine learning are branches of artificial intelligence, they represent different philosophies and excel in different domains. Traditional ML is about making precise predictions and classifications based on structured, labeled data, often with human-engineered features. GPT, with its generative capabilities and vast pre-training, is about understanding and creating human-like content from unstructured data, acting more like a versatile language apprentice. Both have their invaluable place in the evolving landscape of AI, and often they even complement each other. The lines between these approaches are constantly blurring as AI continues to advance, promising even more exciting innovations in the future. Thank you for watching. What are your thoughts on GPT in traditional ML? Do you have any questions? Let us know in the comments below. Don't forget to like this video and subscribe for more insights into the world of AI.